Hey guys, welcome back. I hope you went and grabbed some graph paper or printed some out. So we're going to do question 20 on graph paper. So I have the coordinate -2, 4. (1, 2) and -3, -5. Okay, so what am I supposed to do with these coordinates? Well, first it says line J is x equal 3. So line J is x equal 3. And it also says line K is y equal -2. All right. So the first thing they've asked me to do is to find the coordinates from the glide reflection. And then these are my orders for question 20. I first want to reflect over J, so it's kind of in reverse order. I first want to reflect over J. I'm going to do this first. And then I'm going to translate -2, so 2 to the left, 4 up. Okay, so let's go ahead and graph this. So I'm at -2, +4. +1, 2, -3, -5. Okay, so here's my coordinates. So first I'm going to reflect over J. So let's find out where J is. J is x equal 3. So that's going to be parallel to y. So this would be where x is 3. I go over 3. Right? And I'm going to reflect over that line. So M is 2 to the left, so I need to be 2 to the right. L is 5 to the left, so I need to be 5 to the right. And M is 1, 2, 3, 4, 5, 6 to the left, so I want to be 6 to the right. Okay, so here's my new location compared with my old location. Okay, now normally I'd be done, but I got to do this second, right? So that's 2 to the right and 4 up. So that's 2 to the left and 4 up. New coordinate. Then I do it again. 2 to the left, 4 up. New coordinate, 2 to the left, 4 up. New coordinate. So there's my shape, right? And I can read off my coordinates. So L prime is 3. 1, 2, 3, 4, 5, 6, 7, 8. 3, 8. M prime is 1, 2, 3. 1, 2, 3, 4, 5, 6. 3, 6. And M prime is 1, 2, 3, 4, 5, 6, 7, down 1. All right. Now we're going to do the same coordinates, but we're going to do a different one. So it says translate, but don't do that one first. We got to do this one first. Reflect over K and then translate to -3. Reflect over K and then translate to -3. Let me make sure I copied that down wrong. Okay. So now I'm going to reflect over K. So that's y equal -2. So you can redraw this. I'm just going to erase it. All right. So now I want to take my same shape, same coordinate, reflect over y equal 2. So that would be parallel to the x-axis. So this would be y equal -2. And so notice N is 3 below the line, so we got to be 3 above the line. 1, 2, 3. L is 1, 2, 3, 4, 5, 6 above, so I need to be 6 below. M is 4 above, so I have to be 4 below. 1, 2, 3, 4. Okay, so there's my new shape. And I showed in class, here's another way. Instead of moving it like I did the last time, you can read off the reflection coordinates and then just do it mathematically. So I'll do it this way this time. Again, either way is fine. So I went back 2 and down 1, 2, 3, 4, 5, 6, 7, 8. All right, for M, my new location of M is over 1, down 1, 2, 3, 4, 5, 6. And then N, it looks like I'm back 1, 2, 3, up 1. So now I'm going to perform this translation. So that's when I can just add to my X values, positive 2, and subtract 3 from my Y values. So let's take a look. Negative 2 plus 2 is 0. 8 minus 3. 1 plus 2. Negative 6 minus 3. Negative 3 plus 2. And 1 minus 3. Cool. So there's my answer. Neat. So let's look how we're doing. Okay, so we finished 21. Then it says, what glide reflection for the transformation is shown? So it looks like I could scoot this up, right? If I just took this thing straight up. Let's count how many. 1, 2, 3, 4, 5. Okay, so if I moved everybody up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If I move everybody up 5, that would be, I added 5 in the Y. Then it looks like I need to flip over this line. Remember, I have to be halfway between each number. So halfway between there. So that's kind of half of a box. So it looks like from the origin, that line is not over 1 step, but a half of a step. So it looks like I reflected over 0.5. Now I could also probably have reflected over this first, flipped it over here first, and then scooted it up. So we know that we can do that in either order. And sometimes, and in this case, it will give us the same outcome. So question 23 states, make sense and persevere. Is there more than one way to describe a glide reflection as a composition of reflection and then translation? And I would say yes. I can translate, then reflect. Nice. Okay, let's do this last section. We reviewed lesson 3.5 in class together, and we want to describe 24. And in most classes, we already did that. So it says, describe the transformations that can be used to map the figure upon itself. So here we can rotate, right? It has a rotation symmetry of order 2. Or you could say I can rotate it 180 degrees and it would map upon itself. We also notice it has point symmetry because it has exactly a rotational symmetry of 180. And notice I could also fold it here and here. So I want to also mention that it has 2 lines of symmetry. And we call that reflective or reflectional symmetry. 2 lines. Okay, so for question 25 and 26, describe all the symmetries including reflectional, and identify all the lines. So it doesn't look like I can fold this thing. It won't map upon itself. And the reason is because each length is different. This is short and then medium and long. So that's why it won't fold upon itself. Now this one looks like it would. I could fold it here or here or here, right? And all that would work. So this one, I'm going to say 3 lines of symmetry. And this one I'm going to say no lines. I notice this thing looks the same upside down and right side up. So if this is 12 on a clock and 6 on a clock, it would map upon itself. So I'm going to say that's 180 degrees of rotational symmetry. And that would be an order of 2. It would also mean that it has point symmetry. All right, so I notice here, this thing does not look the same upside down and right side up, but it looks like it has an order of 3. So if this would be 12, and then maybe 4, and then maybe 8, it would map upon itself 3 times. So it has an order of 3. So I could do 360 divided by 3, and I get 120. So it has 120 degrees of symmetry. It will map upon itself. Ooh, last problem. So it states, communicate precisely. Suppose a figure has 2 lines of symmetry. Okay, so that's kind of like our little Minnie Mouse thing here. If I fold it here and I fold it here, that's 2 lines of symmetry. Explain why the figure must have rotational symmetry. Oh, this kind of makes sense because if it maps it vertically and horizontally, see how you can rotate it pieces of 90. I can rotate 90s and eventually map upon itself. Great work, guys. Good luck on the test.